Good day. I am Nir Pasco, so my part of my topic is all about the variation in chemical properties of elements. So the periodic table is very useful in predicting the properties of elements. So ang periodic table daw is very useful yun siya sa pag-predict sa mga properties of elements. So group 1A alkali metals, the members of group 1A are similar very active metallic elements. Their atoms have one electron in the outermost energy level and they tend this to attain the most stable configuration. Therefore, they have low ionization energy and low electron affinity. Cations derived from 1A elements such as si lithium, sodium, potassium, rubidium, calcium, and francium. These cations react with the anions of the elements in group 6A and 7A from ionic compounds, metal oxides, and metal halides. Alkali metals are the most reactive of all metals. So, according to Group 1A alkali metals, so, ang members sa Group 1A kay similar, active, metallic og elements. So, ang ilang atoms kay nag-contain og 1 electron sa outermost energy level. Tas nag-change siya para ma-lose ang most stable configuration. Tas na siya low siya og ionization energy and low of electron affinity. So kani si kaning first A elements such as si lithium, sodium, potassium, rubidium, and calcium, and francium kay ang cation niya is nag-derive siya sa cations. Tas ang alkali metals kay mo siya ang most reactive of all the metals. Group 2A, alkaline earth metals. The members of Group 2A have also similar very reactive metallic elements. These elements donate their two outermost and form cations. Cations derive from 2A elements such as beryllium, magnesium, calcium, strontium, barium, rhodium. So these cations react with anions of group 6A and 7A elements to form metal oxides and metal halides. So according to group 2A alkaline earth metals, ang members sa group 2A kay 6 similar very reactive metallic elements. Tas ang elements niya is nag-donate siya og two outermost electrons para maka-form siya cations. Tas ang cations niya is nag-derive siya sa 2A elements such as si beryllium, magnesium, calcium, strontium, barium o si rhodium. Tas kanilang cations is nag-react siya sa anions sa group 6A and 7A of elements para maka-form siya metal oxides and metal halides. Group 3A boron family. Except for boron, the rest of group 3A elements are metals. Their atoms have 3 electrons in the outermost energy level. Hence, they donate 3 electrons to attain stability. Similar to group 2A, some of these elements react with oxygen gas and acid. So, according to group 3A boron family, except sa boron, so ang the rest sa group 3A elements kay mga metals. So, ang ilang atoms kay naay 3 electrons sa outermost energy level, tas nag-donate siya og 3 electrons para maka-attain siya stability. Tas similar siya sa 2A sa kay ang some of these elements kay nag-react siya sa oxygen and acids. Group 5A nitrogen family. Among the elements in the nitrogen groups, only two are considered nonmetals. The nitrogen and phosphorus and antimony are metalloids. Whereas B is a metal, nitrogen and phosphorus atoms contain 5 valence electrons. Hence, to attain a stable configuration, they accept 3 electrons instead of losing the 5 valence electrons. So, consequently, nitride and phosphide ions are formed. So, these cations react with cations of alkali and alkaline earth metals to form ionic compounds. So, according to group 5A, nitrogen family, so ang among the elements of nitrogen group kay nagkuan siya duha na nag-consider og non-metal. So, si nitrogen, phosphorus, and antimony kay mga metalloids. Tas si nitrogen and phosphorus kay kanilang atom is nag-contain of 5 valence electrons. Tas naghen siya to attain a stable configuration. So nag-accept na din siya og 3 electrons instead of mawala tong 5 ka valence electrons. Tas ang ilang anions kay nag-react og cations sa alkali and alkaline earth metals para maka-form siya ionic compounds. Group 6A, oxygen family. The elements in Group 6A or the oxygen group are also referred to as chalcogen. This is because many of the elements in this group are found in ores of chalcose or copper in Greek. Chalcogen can be metals or metalloids. Oxygen, sulfur, and selenium are nonmetals, whereas si tellurium o si polonium are metalloids. We have 6 electrons to form the negative ions in many ionic compounds. So chalcogens are also found in nature in the form of molecules, exist as the atomic gas, and sulfur reacts with oxygen to makaform siya og sulfur oxide which form acidic solutions with water. So according to group 6A oxygen family, so ang elements sa group 6A kay nag-referred siya as chalcogen. Tas kaning chalcogen kay mo siya ang metal or metalloids. So kani si oxygen, sulfur o selenium is mo na siya mga non-metal. So whereas si tellurium o si polonium is mo na siya mga metalloids. So na siya 6 valence electrons. So tas na siya tendency na maka-accept siya og 2 electrons or maka-form sa negative and many ionic compounds. Tas Group 7A, halogen family. The elements in the halogen family are nonmetals except for 80. Their atoms have 7 valence electrons. They have a high ionization energy and high electron affinity, and therefore has a great tendency for accept electrons to form anions. Anions formed from halogens such as fluorine, chlorine, bromine, iodide. These react with cations of group 1A and 2A, producing salt such as phosphorus chlorine, sodium chlorine, magnesium chlorine, and calcium chlorine. The halogens are reactive, so they can never be found in pure state in nature. They can exist as diatomic gas. According to 7A, halogen family, so ang elements sa halogen family kay nonmetals, tas ang ilang atoms is naa sila 7 valence electrons, tas high ang ilang ionization energy o electron affinity. So na sila great tendency na mag-accept og electron energy dun para maka-form siya og anion. So ang anion sila is naka-form from halogens such as si fluorine, chlorine, bromine ug iodine. Tas kani kay nag-react siya with cations of group 1A and 2A. So nag-produce siya og salt such as si phosphorus chlorine, sodium chlorine, magnesium chlorine, and calcium chlorine. So kani sa halogen kay mo siya ang reactive, tas dili siya makita diri sa pure state in nature. Tas nag-exist na siya as diatomic gas. Group 8A, noble gases. The noble gas atoms have 8 valence electrons that make them very stable. They have high ionization energy and no electron affinity. These elements exist as monatomic gases. So according to group A noble gases, so ang noble gas atoms niya is na siya 8 valence electrons, tas stable, tas na siya high ionization energy pero wala siya electron affinity. So kaning elements is nag-exist siya as monatomic gases. Group 1B to 8B, transition elements. The transition elements have 1 or 2 electrons in their outer energy at levels. They have high metallic property and low ionization energy and electron affinity. Most of the transition metals are hard and have a high melting point. In compounds, the ores are colored. Most of these compounds form brightly colored solutions. So according to group 1A to 8B, transition elements kay ang transition elements kay na siya one or two elements sa outer energy levels. So na siya high metallic property pero low ang ionization energy o electron affinity. So most sa transition metals kay hard o na siya high melting point. So ang ores niya is colored. So most sa compounds niya is naka-form of brightly colored solutions.